All right, so the recording has started, and give me 1 second. Back to the conversation at hand. All right, so what we're going to be doing here, guys, is we're going to be looking at a simulator, and we're going to kind of understand a concept that is what we call super, super, super duper simple. It's one of the hardest things you'll ever do in your life. We're learning that big rocks fall faster than small rocks in water. Bam. That's it. Okay, have a good day. Have a good rest of your time. All right, so this is what I want you to do. Make sure that if you're doing this, what I want you to do for your I guess online for your credit for being in person, the essential question is analyze the difference between the fine, the medium, and the coarse sand, and in how it relates to dropping it in the water and how fast it falls. That's the essential question. So again, the essential question is look at, or at the end of this, be able to tell me the difference between fine, medium, and coarse sand and how it relates to dropping it in water. Okay? So there's that. And what we'll do is for this, we're actually going to complete the lab as well. So by watching this, you also should be able to complete the lab and get that turned in as well. The people in person, they're getting double dip credit, and so we're good to go. All right, so I'm going to go and minimize this, and I'm going to keep talking. If you have a question, I'm going to have to look at the end. And if you have a comment, just try to keep it to yourself for right now, because I'm not going to be able to see it. Because if I do leave this on the screen, there's going to be a black box on the screen, and I don't want that. So we're good. All right, so here's a question for you. If I was to take a larger rock and I drop it, is it going to drop fast, slow, what? Is it going to float in the air? What's happening to this thing? Help me out here, guys. It's going to fall. You're right. But this is what's interesting is that you can't see this, unfortunately, in you can't see this on the internet because I'm doing this here, but I apologize for that. As soon as I get the video to work, I promise I will. But if I throw this sand in the air, do you see that? See that? You don't see it? I'm throwing.
Yeah, I can see it barely. Oh, yeah. Okay.
Yeah? Okay, what I'm doing is I'm actually throwing rocks into the air. This is really, really, really fine, small, basically rocks the size of pretty much flour. Okay? This is what I'm throwing it in the air. Okay, now this obviously didn't fall. It's still in the air. Okay, so what we're going to do is we're going to look and see how this reacts inside of water. So what everyone has in front of them is basically 3 different trials. Fine, we're going to have medium and coarse. What we're going to do is on here, I'm going to drop it into the water. We're going to measure from line to line based on time, take the average, and we're going to see what kind of data we get, okay? Cool. Exciting? Are you excited? Okay. All right. So let's see if I can do this with this thing right here. All right, so I'm taking the fine, which is the bottom one of your part. I'm dropping it onto the top. I'm bringing it down, dropping it back down, turning the water on, and then as soon as the silt hits the red line, I'm going to push the start button. Okay? And what I'm doing is I'm basically waiting for it to go all the way down to the red line. And remember, it's going to shutter for this particular lab. So, oops. Let's do it again. Okay, so I'm picking it up. This is much harder on the surface. Give me a go in the office and grabbing my mouse. Okay, so I'm going to try it again. Okay, try it again. Try it again. There you go. Good for me. Okay, going it and dropping it there. Okay, putting it down, dropping it down. I'm going to go and start it when they. Okay, go ahead and write down 17.2 for the first trial for the fine one, which is at the bottom. It's the last one on the thing, 17.2. Okay, let's go ahead and do this bad boy again. Let's have some fun with this. So I'm going to go ahead and reset it. Go ahead and grab this again. Pick up some of the fine silt. Put it down. Right here. I'm going to start it again when it hits that red line. Okay, and what we're going to do is it's going to go through. What do you think numbers should be? I mean, right around what time? 17 seconds. Okay, so approximately 16.8. So go ahead and write that down for your second trial for your fine trial 2. Okay, reset. Grab the fine. Drop it down. Okay, and this one, what do you think it's going to do? Oh, open a PowerPoint apparently in the middle of it. Okay. All right, so it's shuttering, it's making its way down, It should be hopefully right around 17 seconds is the goal. 17.3, so go ahead and write down 17.3 for the last trial. Now this is the hardest part of the whole thing. Please take the average. Take the average of your 3 trials because it's asking for the average on the far right hand side. By the way, online, since we're doing the lab, you can definitely write this data down, write this information down, but I do recommend typing it into your data on the actual lab sheet, which I actually printed out and gave everyone here. Yeah, whatever it is, it's math, so do it. Yeah, it's not what I think it is. This is very concrete. Add them up and divide by 3. You can use your calculator. You can use a phone. You can use your brain. Yeah, no, hey, you can just do it in your head. I was busting out in my head last class. I was like off by what, 5/100ths on one of them, but bam, I was right on with the rest. All right. So while you guys are doing that, I'm going to go and reset this, and I'm going to start and actually do the medium. Now, do you think this is going to fall faster or slower? Okay, because it's bigger, maybe. Let's see. That's what we're finding out right now. We're going to see if you're right. So what I did is I did it, and it's going to shutter up here, but you'll see it towards the end on this side. Shutter means it's shutter is kind of like lagging. Yes, shutter is lagging. It's 9.9 seconds. This is for the medium trial 1. Medium trial 1. Okay, let's go ahead and reset that. Do this bad boy again. Okay, medium trial 2 is a go. Hopefully this is right around how many seconds? 9 to 10. Yeah, hopefully. The reason why I bring that up is that, bam, in your face 10. This is the reason why. If I take one trial and I come up with a number, I would hope that the rest of them are pretty close to that. That's why you're supposed to do as many trials as you can. Don't throw things out. Relax. Relax. I know you're angry, but it's okay. Just keep up. What you want to do is hope that you're on 10. Now, say I did it, and for whatever reason, it was like 30. Obviously, something's wrong. I probably picked up the wrong type of rock and put it there. Okay, so just make sure you have some of the common sense of knowing that they all should have right around the exact same type of fall. That's the assumption. We're doing medium one more time, real quick. Drop it in. Good for me. Put it down. Okay, waiting for it to hit, and boom. Okay, so hopefully this is right around 10 seconds. And again, on your side, you're seeing it kind of jump and not being very fluid. I apologize for that. It's called 10.1. So it's called. Yeah. So go ahead and take the average of that. Should be probably 9.9, 99.9, or it's 10. Is it was it 9.9, 10, and 10.1? It's correct. That's my final answer. Okay. All right, so I'm going to go and reset this. I'm going to go and pick up this bad boy. I'm going to use the coarse. This is the bigger rock. Will this be faster or slower? Let's see. Starting this. This one I actually got to pay attention to. .9. 4.9. You said slower? And are you right or wrong? Yes, logic would say that you were. Yes, obviously, it was much slower. No, you see it's going faster. Bigger the rock, kind of harder it falls, the faster it falls in this case. Let's do it again. And it should be right around what, hopefully?
4 and 5.
Between 4 and 5, let's hope. Bam, 5. Good for me. You're going to see that in a second. There it is, 5. All right, let's do one last time so we can move past this not as awesome part of the... Ah! No, go back. No, no. No, go away. Ah. Give me a second, I got to let this mix stuff. By the way, I guess we can do this now. If the half the mix, or if this is a mixture of the fine, the medium, and the coarse, obviously what you're going to see is a separation. You're going to see it break apart, and it's going to sediment. Basically, the bigger ones are going to fall faster. The sediment's going to fall shorter, and it will actually separate in the water. So one of the reasons why in a river you see rocks on the bottom, and you spill the water, it's brown. And the reason why a lot of those waters is muddy or brown or red or whatever it is because of the silt or this type of powdery substance that is a rock. It's still floating around in it. It's basically just kind of basically floating. And it's going to stay like that until you leave it alone, and it will eventually still settle. But it's going to stay up there until you allow for that gravity to take place. Let's do the last one of the course. I got it right. Yay me! My mom thinks I'm very smart. Hi. Bam. No, my brother's actually extremely smart, but doesn't make good decisions. He's very smart. Okay. So approximately 4.9, I don't know, whatever it is. 4.95 or 5.975. All right, so there you go. So what we've gathered from here is basic knowledge. Big rocks fall faster in water than the silt or the sediment. Now this actually makes sense because if you look at a river, all the river's rocks, the big rocks are still in the river, but as you go downstream, the rocks will get smaller and smaller and smaller and smaller, and eventually become very muddy in the delta area. And so as you make your way out, it will become very, very thin. Now, if a river that has a lot of force, like the Amazon River down in South America, could actually push sediment out several miles. Okay, so it comes in, it drops the bigger rocks drop off first, and all the sediment, the really fine stuff, gets pushed out sometimes miles out into the water and settles. It's one of the reasons why the rocks here in the Ortegas are really big rocks. You don't get very much sand up there. But as you make your way down the Ortegas to the beach, you get sand. It started in a mountain one time. Every single piece of sand at one time was a rock. I mean, a large part of a rock. And it broke apart through erosion, and it made itself smaller and smaller and smaller. And all those little pieces of sand, as they slam into each other there on the beach, will break down and get smaller and smaller and smaller, and they get taken back out into the ocean. And the further it goes out, the softer the sand will be. Okay? That's it. Bigger rocks closer, smaller rocks get pushed out further. So let's go ahead and look at the next part of the lab. And what we're going to do is we're actually going to be looking at, as soon as I find it, we're going to look at some sediments. And in this sediments, we're going to look at it in, give me a second here. It'll take a second for it to load on the internet. Okay. Currently, all of a sudden, my pop-up blocker happened. Good for me. Okay, so give it a second. This one, the good part is after it shutters, we're not moving very fast, so it won't be that bad. So what we're going to do now is on your back side of your paper for the people here, or page 2 for the people at home. You'll answer 2 and 3 on your own. But what you're going to do is now focus on part B of examining rock samples. Now, a lot of people, when you look at a rock, they have no idea where it comes from. You just look at it and you're all, cool, it's a rock, let me throw it at my sister. Okay, you don't look at it. But actually, I'm kind of a nerd. I'm a nerd when it comes to that, where like, I'll be at the river, and I'll pick up a rock and go, wow, this rock doesn't really fit this area. This is weird. And I'll look at it, yeah, don't look at me like that. Yeah, that's what I do, okay? I'm not very fine. I feel like there's judging. I see judging in your eyes.
I'm judging.
And I feel like there's judging coming from you. All right, so you pick up a rock and I look at it. And based on how it looks, what it's composed of, I can kind of get an idea where it came from. So, like, I remember one time at the river, I picked one up. My friends are very bright. And they're like, where did this come from, man? You teach science. And they, like, hand it to me, and I'm all, yeah, I teach science. Doesn't mean I know everything. Of course I do. And so I look at it. And obviously, based on what it looked like, the size, the composition, how it's rounded, not rounded, things like that, I can tell it came from the mountains in the distance, because there's nothing in the area was based on it. It was getting pulled down by the river over time, probably millions of years, and I happened to just pick it up. So what I do, I threw it out. All right, so this is what we're going to do. We're going to look at the various samples of what we don't know what they are, but we're going to take a guess what kind of environment that they came from. So up here you will see, I'll do this up here. Okay, I just want to make sure you guys can see up. You're good. All right, you're good. All right, so let's look at this piece of paper, or I'm sorry, let's look at this sample as soon as it decides that it's going to not look like a 1980s video game. Wait for it. Wait for it. And whew, thank goodness, we're good. So let's look at a few things. We're going to look on your paper. Is it going to be biogeneous? Is it going to be heterogeneous? Is it going to be round, angular? Is it going to have any else characteristics, and what type of environment it comes from? So we got to look at a few of these, what these mean. Because if I just say, oh, it's biogeneous and heterogeneous, you're like, what are you talking about? And you're not really following me. Okay, heterogeneous. Anything that says terra. Okay, heterogeneous, terrestrial. Is that T-E-R-R prefix? Basically means like earth, from the land, rock, from like it's round. Huh? But then there's the one that's called what are they using? Biogeneous. Bio is life. Anything that was living has once been lived or created by living things. Okay? So when we look at these, you'll see the obvious ones right now. Do you see anything that was living there? And by the way, last class had bacteria and algae, and they were both right, probably, but I told them to go away. Because it doesn't work. But right here is just rocks, right? Now, so on your paper, you're going to give a percentage. Do I think it's 100%? Do I think it's 50%? Well, there's no biogeneous, so 0%. It has to equal 100. So what do you think the other one is? 2%. No. 100. 100% heterogeneous, 0% biogeneous. Does this look rounded? Or does it look angular or broken or cleaved? Angular! That's what you want to write there. Angular! Now we're going to start talking about geometry. Anyone ready?
What?
What? No! He starts running out the door.
How's an option?
That's how you're editing? Yeah, we're going to be doing geometry. Alright. So the next thing is there any special characteristics? I don't know. I'm just right here that looks like there's some light color, some tan, some darks. They're smaller. That's a small rock. I don't know. I would say, what do you think the environment came from? Well, for one thing, it's not rounded. Okay, this is an important thing. Not rounded. Therefore, it's not around water all the time. No, this isn't in the river. This isn't in the river. This isn't in the ocean. Right away, you already know that just because it's angular. Okay. Next thing is a bunch of mixture of different types of colors. Okay? Desert, when you go there, is a bunch of different types of colors like this, or is it maybe more tan? Okay. We'll get to the desert in a second. Yes. I would say that this one was maybe a base of a mountain. Could also be like in this area type of thing, where it's far enough away from the mountain where it's broken down enough, but it's not near a water source, and it's not just sand. Let's look at the next sample. Sample number dose. 2. It's 2 for people who don't know Spanish. Okay, so we're looking at this, and eventually, again, it will eventually show up when the 1980s video game decides that Donkey Kong is going to win. Sorry, what's funny is I have the student view up on my side so I can see like what you're seeing, and that's really hilarious that that's happening. Seems like the internet should be faster. All right, so what do you see there? First of all, do you see any living things? No. So the 100% is what? Stereogenic. And it'd be a 0% biogenic. Rounded or angular? Rounded. You see that? Which round? I don't know this rated. It's so rounded. Okay, and also, what are some special characteristics that you see on there? They're clear. That's important. Clear is more like, quartz, things like that. Okay, it's not basaltic. There is maybe one piece of basalt. It's on the right-hand side, a couple specks of it. It's the black color. That's going to become from like lava volcanic activity. So, where would I find a bunch of clearish type of very small rounded rocks? I know, literally everyone's all good. You can say cave? No, could be, but let's say no for right now. Could be, but let's say no. Where do you think a whole bunch of small rocks that are rounded, that are a tannish type of clear look, which looks a lot like this? Where would I find this? Bottom of a fishbowl. That's it. That's where all of them are at. That's it. That's it. Let's all go home. Now, where do you think the bottom of that fishbowl stuff came from? Naturally. What part of the ocean? Bottom of the ocean? Maybe, maybe not.
Yes.
What is this? Where's sand at? What specific place of the ocean? The beach. Thank you, because the sand at the beach is different than the sand when you go out 300 yards. It's softer out there. Remember we talked about how silt, smaller silt makes its way out further away from it? So this, basically, this right here is sand from the beach. Jamaica Bobsled Team. Never mind. Good movie. I recommend it. Yeah. Jamaican Bobsled Team is when the Jamaicans went to the Olympics for bobsledding. That's why it was so awesome. All right, yeah, it was before the birth of the children in the room. You are old. I just want to break it to you. Not like me, I'm young.
You're old.
You're probably younger than me. I'm 32, what does that mean?
You're really old.
Just for the people on the internet, one of the hopeful helpers in our class said that they are 24. And one went, geez, like, wow, that's like 10 years older than me. And then I say, I'm 32, and she looked at me like I'm literally a walking dinosaur ready to be preserved. Well, like, and you can still move, Mr. Hayden? Wow. I didn't realize people live that long anymore. Thanks, I appreciate that. All right, let's look at this one real quick. All right, so what do you see? Do you see anything that was alive or at once was living? What are those big things in the middle? Shells. Where do shells come from? Animals. Animals. So those are called biogenius material. So in percentage, I don't care, okay? Maybe 20% of the thing is biogenius, the other one's 80. Really, I don't really care. I just need to know that you at least know there's not that much there. And you can tell the difference between a rock and a shell. Okay, I don't want you guys to go to the beach and go, Mommy, Daddy, look what I found a rock, and it's a shell. Because then I'm going to do it, and I'm going to quit my job. Okay,
That's all we have to do to get ready?
do it. Yeah, no, that's videotape it. All right, so next one. Push the button. I don't need to put any type of media to receive the data. And so where do you think this came from? By the way, is it angular or is it rounded? Rounded. Thank you. And where do you think this came from?
The ocean.
The ocean, the beach, probably right on the sand, actually. Literally, like I'm walking down the beach, I grab a handful of stuff, of sand, and I pick it up and I look at it and it looks like this. Have you guys actually even really looked at a rock closely?
No.
Like took sand and like you know, you're just like bored one day, so you really want to look at rocks. I don't know. And so you like really get looking at it. What you're going to find is that a lot of it's clear. Quartz. They're little crystals, basically. A lot of people don't realize that because of the way the light hits it. Okay, so next. You can make crystals if you wanted to. But you can make them out of sugar. Sugar. Okay, give me a second. If someone has a question, let me bring up the 1980s thing. Good, more German. Yeah. All right, let's go back. All right, so looking at this, and by the way, wait till the 1980s video game. Donkey Kong, which is the original video game that has Mario in it.
Yeah.
Original movie, original one, Mario's very first appearance has been over 100 and something of them now. It is. Let's pay attention. Focus attention. All right, so over here, you look at this now, and you have unknown samples, but I'm looking at this. Do I see a little bit of shells or a whole bunch of them? Whole bunch. So you can even just say at this time it's probably 90% biogeneous and 10% pteridine in this case. What do you notice about the rocks?
Angular.
Well, they are angular. Very good. That is a good point. The rocks are angular. Very good. They're dark. They're black. They're basically lava, broken pieces of lava. And so, in this case, there's big broken pieces of lava with seashells all the way around it. Am I looking in the desert today?
No, you're looking at Hawaii.
I'm looking maybe at Hawaii, but in general, not just a state. I'm looking in an environment that has volcanic activity and living things. Probably maybe a what?
Undersea volcano.
Maybe undersea volcano. It could be a volcano next to the ocean. It could be any of that. So we're all in the same area, okay? I mean, the same concept. I'm not going to take this. I'm not going to like look at this and go, oh, I need to look this up. I better go to Antarctica and start digging in the snow. Okay. No, you're going to say, hey, I better go to Alaska where there's volcanic activity, Hawaii, other places in the world where there's volcanic activity. All right, this is probably near also a coast, like a coastline, probably offshore, like a oh, whatever it is, a reef. Okay, so sorry guys, I apologize for the script reading, loading, being so slow. I'm waiting for.
It looks like palm.
I'm seeing the same thing.
Someone to that last class. They're like, it's bacon! I know where to get that! Just go. Alright, so looking at this right here, do you see any living things? No. Do you see mostly terrestrial or pterogeneous?
Yeah.
Yes. So 100%, 0 on the other. Is it angular or rounded? More, it looks like jagged or angular would be a correct statement. Any characteristics that are important? Looking like bacon is not a characteristic. It's awesome, but it's not. What is it?
Red.
It's red and rough looking. So where would I find red, rough rocks?
The donut.
Not a specific place. You go to 35 East Melville Lane, look to the right, underneath the basket, and that's the color. We're talking very broad here, guys.
Yeah.
Where do you see this at? Desert. Probably more towards Utah. It has a high iron content, hence the reason why it's red, it's rusted, it oxidized. Grand Canyon, which is part of big area. Grand Canyon is a whole bunch of states, kind of all jumbled away. But yeah, in that area basically. Also on the way to the river, you can see the style rock in the strata as you're driving. The strata. Strata is layers of rock. So like when you look at something and you see like layers as you're driving, like out in the like desert, each one of those layers is a different time of what happened. So like it's really boring, but like I find it fascinating because I'll look at the strata as I'm driving because what else am I going to do when I'm driving to the river? Talk to my wife? That's not happening.
That's boring.
Yeah, that's not happening. Dang it, it happened again on the YouTube channel. Alright, whatever. So as I'm driving, I'm going to see a strata. So I'll see like a dark strata, a light strata, and what happens is that tells me at different times that this area was either underwater, volcanic activity took place. I can literally know what happened in that area over time by just looking at that. I think that's fascinating.
I did that too, and then I found Snoopy.
You found Snoopy.
Seriously, good.
Thank goodness you found Snoopy. I'm pretty excited about it. Yeah, good. I was just I'm happy for you. You should show it to me. Okay, so looking at this, what color? Or I'm sorry, anything living?
No.
No. It's all pretty much rounded. There's a little bit of angular, but let's just say rounded. Any characteristics? Smooth. Some of it's smooth, yeah. What color is it?
Wow.
Which is different than everything we've seen, right? I mean, all black. I mean, not the other one. That one had black, but it had a bunch of shells. No shells, but it's very nice. So, if it's dark rock, where'd it come from? Lava, volcano. Very good. I'm glad you didn't give me like very specifically the Big Island of Hawaii Island on the east-western side, 45 feet off the water on the left, underneath that other big rock. Okay, I'm glad you didn't do that. Yeah,
I'll do
this
that
is
next
going to be
time.
volcanic. It's rounded, so it's near water. Okay, so maybe this could be a volcanic stream area. It could be near a beach doesn't have shells right now. So maybe they're not living in that area. I don't know. But that's how I would go to locate this area. Okay, last one. Let's wait for the thing that happened. Is there a question? Let me see while this is shuttering. Let me see if I have it. Okay, now you're speaking Arabic. Good, good, good. Well, he's writing in Arabic. Or writing in whatever specifically that was named. I don't know if that's what he's writing. Okay, sorry, let's wait till it goes. Now, you guys can kind of see it already. What do you see? Do you see any living thing? Okay, good. So it's 100% heterogeneous, awesome sauce. Do you see, is it rounded or is it angular? Rounded. What colors are they? Whole bunch of different colors, right? What does it kind of look like to you? What things do you see that this looks like? Don't say rocks.
It's raw.
We smell like colors. Guys, in your house, do you guys have granite?
No.
Count it.
I'm getting some.
That looks like your granite countertops if you have granite. Guess what your granite countertops is? Volcanic rock that's stuck inside of a mountain and cooled down over time. That's what it is. Then they cut slices of it, they polish one side and set it on top of your cabinet. That's what they did. That's what happened. That doesn't matter what it is, it's still volcanic. But right here, this right here is going to be granitic rock. It's rounded. So granite rock that's rounded, where would I be looking? Where's most granite rock at? Say it louder. Mountains. She's 100% right. So I'm in the mountains now, and I'm looking for something rounded. Where would I look? No. Place where there's water. Where would be a water in the mountains? Don't say lake. Stream or lake. Very good. This right here is stream lake rock. So there's a stream or river rock up in the mountains. That I can guarantee. Probably near either the bottom of the edge. I'm sorry, towards the edge of the water itself, or it didn't fall into the very pit of the bottom. It probably is towards the end of the river where all the boulders are at the top, and there's the river rock at the bottom. This is probably closer to the base. And guess what? You guys are done. So give me a second. I'm going to go and finish up a quick statement for the online piece and for you guys. Make sure your science notebook is coming along. If you have no idea what I'm talking about, you're going to miss 100 points at the end of the semester. Make sure you actually watch the orientation in week 2 if you have to review it. Also, the directions are inside the class, left-hand side at the bottom. Okay? Want to make sure that you know that, and that's very important because it's 100 points. If you have any questions about science subjects specifically, please make sure you ask me, and I'll make sure.
They did an outline of it.
Someone's showing me Pluto rock. Okay, you're right. You were technically right that someone randomly made a name for a random rock in a random place. Good job.
Yeah.
All right, so make sure you do that, and also make sure if you have a D or an N or an F that you are coming to school. Remember, you have to meet with your homeroom teacher, or just pick up a goldenrod sheet. Yeah, I will sign that paper, and because it's something I need to do. Make sure your course number is on that, and we're good. All right, have a good rest of your day, and make sure you guys sign up. Can you hold up a second? So we're going to go ahead and stop the internet real quick, and I hope you have a good rest of your day.